As I was saying, the desktop version of ArcGIS is kind of a Swiss Army knife. It has a million different functions, something like Microsoft Office. The mobile versions, the clients, are really only intended for viewing and maybe some very light editing. There's some built-in functionality for editing features. You can add more of that if you feel like developing and adding some server side stuff to receive the edits you make, but for the most part it's just displaying stuff in different ways. And ArcGIS has a lot of different client applications that you can target. There is WPF, Silverlight, and Windows Phone, which all kind of draw on the same code base for the most part, all have a very similar API. And they've also got stuff for iOS, they've got stuff for Android native apps, and they've also got their JavaScript framework. And as I mentioned earlier, all of these are structured in the same way. If you dump into the API, you'll see that they have layers named to the same conventions, maps, classes, all sorts of elements named after the same conventions, and then put together in mostly the same ways as well. So your knowledge of one is semi-portable to develop it with the other clients. Why ArcGIS? We kind of had this discussion already, but it's some of the things that it definitely has that many other options don't is a good quantity of documentation. Not always of the very best quality. It's kind of a large corporate style product, and you really need to read quite a lot of what they have written out there before you to catch all the little caveats in order to get the development going. Yeah.
One thing I'll add on top of that is there is documentation for ArcGIS stuff. It is just not always easy to search for. So
yeah,
one of the good tips is to like find a good source of like once you found a piece of documentation, sort of bookmark it and reuse that. If programmers were kind of used to just Googling things, like you put in your error or whatever, that doesn't seem to work very well with ArcGIS.
No, not as well. There is at least a developer community that you can detect, which I found was not really the case with Web App Server. There was so few people out there working with it. There's a pretty decent number of features, even on the client side. There's quite a lot of features. A lot of them you're not going to find a lot of use for, but every so often you'll try something out and say, hey, that's actually what I can get to use out. We talked very briefly about the licensing. So most of the time it's free, that's the top part. Some of the time it is not free and they don't give you a price. It is free when you're just doing the development before you deploy it. It is free for educational purposes, which is most of what we do, research. It is free if it is public facing, although they don't really discuss that here. It's also supposed to be free if you have a server license. I suspect that might be different for us because we're site licensed as an educational institute. That would be something we'd have to ask the University of Calgary, or the department that's in charge of licensing that for us. And kind of difficult to comment on what the price would be otherwise, but if you're staying within these bounds, you shouldn't have a problem with the licensing. Although once you start mixing and matching the clients with other servers, then you start to get into more interesting setups. So to give you a very basic idea of what building an application looks like to begin with, I've put together a really short walkthrough of WPF. And it only manual my code slightly, so that's not too bad. You download the APIs from the Azure website and you include them, and once you're up and running, this is a XAML document. Really easy to just drop a map object into the XAML file and then start adding elements to it. I added a layer here. The GIS dynamic map service layer is a long way of describing a layer that does a lot of work for you. It pulls a layer hosted by an ArcGIS server from the net. You can see the URL there, and displays it in tiles. So as you zoom in, it will intelligently display raster tiles that are of higher resolution in that area. You can add lots more layers to the map in the exact same way, just adding those tags. Esri provides a decent selection of base maps that you can work with. This is kind of a selection, which will kind of define what the backend of your map looks like. And then you can add additional layers on top of that, either layers that you
can you overlap one base map with another?
No, they're basically opaque. So you can load multiple base maps at the same time, but you can only really show one at a time. We did that with eGrid. If you've ever seen an application, you can turn off the road map and view the terrain map, which was a satellite imagery map.
But you can make them transparent or something like that.
No, you cannot do that with base map.
I don't think there's a way to make them semi-transparent or anything. No.
Part of the other problem too is typically, this definitely with an ArcGIS, the first map that you load becomes the standard spatial projections. Like the projection on most spatial reference is the standard one. And then it'll reproject every other one you add on top of that for you. So the standard base map is sort of like special.
Yeah, we'll discuss projections briefly later, but it's something you always have to keep in mind when you're doing anything with that. So the map I chose to play with was their oceanographic map, because that was new to me, and you can define the extent, the area that you're looking at also in XAML. Drop in an extent tag. I've chosen this chunk off of Vancouver Island. And similarly, there's a whole bunch of, as we get to other layer types, you can also, if you want to keep going in XAML, you can begin adding other elements inside of those tags and get more stuff shown on your map. This is kind of a contrived example, because there's only one dot onto this map. But you can see the graphic tag defines a single map point. You can define the style of it. You can define the location of it. And this is the point where I will start talking about spatial references. So within Esri's client, every object that will exist in your map will have, or is remotely related to the map, will have a spatial reference attached to it. The map has one, the layers have one, the graphics and everything else have one. Basically, you need to set these whenever you can, or things will just start going wrong.
If they're not set identically, will the client actually do the transformation?
No, it will not do very many intelligent things with them, I promise you that. The first layer you add to a map defines that map's spatial reference, like you said. And I believe that every graphic you add after that must be set to that map's spatial reference and must use the same coordinates as the map's spatial reference, even if the layer you're adding to is not of that spatial reference. So you'll be adding points to a layer, and you'll be sure you've used the right coordinate system. And they will be appearing nowhere near where they're supposed to appear. You'll be wondering why. This is one of the reasons why. So the spatial references, coordinate systems in Esri are handled with these well-known IDs, WKIDs. 10 or 102.100 is the ID for web mercator, I think. One of the more commonly encountered ones. There's IDs for WGS84 is another one you'll run into.
I finally found a macro list when I was preparing my presentation.
Yes.
Yeah.
I've got a link to the list because that's one of the most useful things to be able to do is to look up a reference system by name and find out what its ID is. These IDs assigned by Esri. Or if you've got an ID to figure out what is it actually describing this thing. Is it some web format? Is it some national reference system sort of thing? So we talked a little bit, actually we've already talked quite a lot about compatibility. There are standards for web mapping, which is KML. It actually stands for Keyhole Markup Language. I don't know where Google got this. I don't know exactly what the origin of that game is. Web
I
mapping
actually bought a company named Keyhole that developed that stuff.
Oh, well there you go. That's news to me. So these standards are supported by Esri's toolkit. I was just checking the API actually prior to this, and yeah, they do have layers that say KML layer, WMS layer. So in theory, you can just plug in a URL, much like we did with the Esri service here, and it will load that service and display it in your client. So in theory, you can mix and match, but you do have to kind of be careful with licensing because the clients especially have licensing that says you can only use this if they're public facing or if you're doing it for educational purposes.
That generally tends to be true for the base maps, and you also have to be really careful if you're working with GIS data. The school has a huge advantage. They have like a whole desk. It used to be called the Rock Desk or something like that, and you could get a bunch of this geographical data for free. But real geographical data, like for specific purposes, is hugely expensive. One of the GIS things I didn't put in my presentation, but there are whole companies that just exist for doing surveying and stuff. It costs tens of thousands of dollars. So yeah, like that GIS, the licensing on it can be really dicey.
Can I access an ArcGIS base map from a non-ArcGIS client legally without paying for it?
You probably can't even technically do it because the base maps I was highlighting before, they're provided in Esri's web mapping format, not in WMS, I believe. So you pretty much can only use these with their software.
So Esri base maps only go with Esri clients, but your Esri server can serve whatever framework from anyone.
Exactly. Yeah. One last comment on developing and adding for WPF is that one slightly painful thing about the API is that you can do everything in XAML and you can do everything in code. And it all works relatively well, but it's not really clear where you should draw the line between the two. So defining maps, defining layers works very well in XAML most of the time. Defining graphics, as you can see here, is kind of a pain. If you need to do many dots, you have to have an enormous soup of tags. So this is one task where it starts to make sense to do that in code. But one thing to do when you're starting a project or going into a project is to try and settle on a convention, because if you end up defining some layers in code and some layers in XAML, you will end up with kind of a mess that can be a bit difficult to follow.
That's kind of a standard WPF thing though, right? Like,
yeah, I mean, the idea is that you're separating the behavior of the application from the appearance of the application, but
I think a reasonable approach is don't do anything in XAML that if you had like a traditional GUI interface builder that you would not do in the GUI interface builder, even like
Yeah.
you can.
And with regard to these graphics as well, I've got an example of an application I built with more advanced graphics, because that's just dots, and you can also get lines, polylines, you can put polygons on there that are regular shapes or spheres or whatever. And you can style these on the server. When you can serve layers that will drop graphics into your application, or you can style them locally. You can mix and match them as you want. And these graphics, these features as they're called, are pretty much the only elements that are supported for editing built in. It's easy to do it programmatically. It's more difficult to support it in with a GUI that a person can actually add and do things with the application, but it can be done. And last of all, I'll just highlight some of the resources that I found really helpful while I was doing this type of development. There's a base app collection that I've shown you already. The Silverlight Interactive SDK is at the very top of the list for useful tools to have doing this sort of work. It's Silverlight runs as a plugin in your browser, and you can see how all these features work live. You can play around with them, add things, or see what they do on the map, see how you interact with it, and then you can go into the code and make it work. And it happened a lot with my application, and I know it's happened a lot with previous people who worked on the application, is you can just take code right out of this. It has to be usable and do things in your app. Resources that ArcGIS.com is just their hub for all the API documentation. It's possible to run S3's WPF applications on the Surface One. I found some code anyways that allows you to do that very easily without having to do hardening work, even though that's not supported natively. You don't have the touch support for the Surface One in ArcGIS, so that's kind of cool if you're thinking of supporting that. And last of all, spatialreference.org. There are several sites out there, but this is one of the better ones. It's just a list of spatial references that is searchable, so you can figure out what is this coordinate system, what is this data I got, where is it supposed to be. It's really difficult to figure out what data is, where it's supposed to be just by looking at it. You pretty much have to know how to get the spatial reference system right, so that it will go to the right place the first time you use it. And useful to have that kind of resource.
So the bottom line, when you look at the APIs from S3, they are all structured pretty much in the same way. But
really
the set of features that are provided depends on the API that you're actually using. So WPF has the broadest support, Silverlight is probably quite close. JavaScript, iOS, Android simply have the same structure but less features.
Yeah, that's my impression of it. Like I said, I haven't had a chance to look at these APIs really in depth, but it's apparent right from the first time you look at them that they all have the same sort of
naming and structure.
naming structures.
Even if it's weird within the framework that you're using, they'll try to stick with the standard.